I chose to do an applet that I found from the NCTM Illuminations website. The activity I am looking at is called Fractal Tool. Now, the nice thing about these activities is it gives an explanation of what the activity is. It also gives instructions on how the activity works, what you need to know in order to instruct students, or you may have your students just go straight to this section and read it themselves so that they know what is expected. It gives an outline of what the exploration is, of discussions that teachers could have, of what you can have your students do on this applet. And it also has related resources. Now this resource is a lesson plan entitled How Many Triangles Can You Construct? And I will open that to see. Okay, and what they do is they have questions, they have an example of a table that you might use, and suggestions of how to conduct that activity with students. Now let's take a look at the Fractal Tool. In this tool, they have different fractals available. So we'll start with the snowflake fractal. Okay. Now, what we start with is a triangle. And if I hit the plus, it will add to my fractal. As I continue to do that, you can see that the table is continuing to grow. It has the stage, the number of segments, and the total length. This is something that the students might use in the activity that you are conducting, or you might have them create their own table. I personally would have them write their own table where they're also counting the number of points, exterior points, or possibly the number of points that are pointing inwards. Okay, now you can continue to grow your shape, and eventually it will reach a point where it does not continue to show on the image, but it will continue to show over here on the table, and you can see the blue represents the additions to what the image would look like if we were continuing on the image. This is useful for constructing formulas, finding relationships, and so on. In addition to the snowflake, we also have the fractal tree. Now this time I'm going to push the play button, okay? And it grows without me having to add. As you can see, it will keep growing, so I'm going to stop it there. The table continued to grow. There is a zoom in option. Unfortunately, with the fractal trees, because there are so many line segments, it is very difficult to see the separation between them. That is where this table comes in handy. Okay. There is a square, a fractal square. And as I add to it, you can see, now this is an interesting topic you could talk about with students. Are we adding to the inside and making it smaller, or are we adding to the outside and zooming out? Okay, and each time I add, it gets smaller and smaller. Another column I would maybe add for a table with this would be perhaps the area of the new square, and you could form a relationship creating an equation of how big the squares are as you add to this image. That's something where you would have to decide, are we adding to the outside, or are we adding to the inside, making it smaller? Okay, now the last shape that they have available here is the fractal triangle. Okay, this is an activity that I could also use paper and tape and have my students create this As a hands-on activity, what you could do is have them make their own pyramid, 3D pyramid, tape it together with 2 other piers, which would make a bigger pyramid, and take 3 groups pyramids and tape those together, forming your own type of triangular fractal shape within the classroom. Now, when you're doing these activities, there are questions that you could ask your students. For example, how does the image change with each step? Okay. Self-similarity is every shape within these is similar. For example, here every shape is a triangle. When we did the fractal snowflake, it had triangles. The points coming out were the triangles. And obviously in the tree they were line segments, and in the square, the squares. Okay? How does the number of segments, squares, triangles change from each shape, from each stage rather? Is there a relationship between the second and third columns? What values will appear in the row for stage 16? What values will appear in the row for stage N? And these are things that we have explored in this class. If we continue on this table, what will be in the nth term? There is an option where students could create their own. I think it is more beneficial to use these fractals that are given, a little bit more direct. You can guide the discussions that way. Okay, and that is what I have for the Fractal tool. I think it would be a great applet to use in upper elementary grade levels, and also maybe in junior or senior high schools. One last thing I'd like to add too is if you go to the related resources and this lesson plan, it doesn't show a whole lot here. I did download it and it was several pages long. It gives you the standards, it gives you the objective, and it gives you step by step what the lesson would look like, how to relate it to maybe other shapes, how to relate it to different patterns. So I find this extremely, there's the list, materials, assessments, questions, reflections. I find this tool extremely beneficial when planning out a lesson. Okay, so that is the Fractal tool, and I hope you enjoyed.